simpler ones, the primitive ones. Then after that we go to more and more complicated statements. This one is fairly complicated. It can be written here. Okay. So now we come to the conjunction of these two. So regarding the conjunction of these two, this is true only when both the statements are true. So this is true only in this case. In the other cases, at least one of the statements is false. So they are false. Okay. Now we also need the negation of the disjunction of x and y. So we need to change the things in this column accordingly. So we have f, and in place of f we have t. We have replaced f by t and t by f. So now you compare. These are the same. They are either together true or together false. So that's why these two statements are logically equivalent. This is one of the De Morgan's laws. The other you can prove like that. Okay, so you please try to prove the things I haven't proved here. I mean these laws, the way I have shown you. This is the standard and most convenient way of proving them using a truth table. Okay. Now comes the remaining construct that I have told you about. I told you that one more construct is there. One more is remaining. It's called implication. And this is presented now after having all the others, because it is the least intuitive one. For statements x, y, the implication is defined as follows. This is also a compound statement that starts with two other statements, and it looks like this. Note that it is one half of if and only if. If we have like this, it is one half of, we will see the actual, that actually it is only a half of double implication. That's why we also call that double implication. If and only if is called double implication. Now this goes in only one direction, and what it says, it defined means we have to, what do we have to do, say in this case? We have to say when this is considered to be true and when this is considered to be false. That's the thing, that's the definition of a statement. That's all we need to know about a statement. When it's true, when it's false, as far as mathematical logic is concerned. Now, unlike the other constructs, in this case, we cannot at once say it's truth or falsity. That depends on truth or falsity of this. Now, by the way, there are some names or terms that are used. If you remember, I have told you about a general structure of a proof that starts with some hypothesis then that leads to a conclusion or a set of conclusions. It's that thing only. Okay, so it's defined. Okay, let me first define it, then I will say what x and y are. I have already mentioned it, but I will say formally. If x is true, we define this to be true when y is also true and false when y is false.